This is like I've just barely put my office studio back together.
You're coming to us from a very dark place, which seems to be a good metaphor for the end of 2023.
Okay, hold on. Okay. It doesn't have to be this dark. What? Oh, there. Okay.
You are quite loud now. I shall turn you down a bit. Okay. You're giving it the evil stare.
Okay.
Did you at least have a good drive home?
I mean, is 4 days of 8-hour drives good?
I mean, no.
Yeah. All right. So there's lighter. That's pretty light.
Okay.
Okay.
And this is where everyone gets to see just how dramatically different we are in skin color.
Well, I haven't even white balanced this camera yet, so.
Well, I know that the bookcase behind you has the right colors.
Okay. Okay. All right. Well, I did spend a month in the sun, so.
And I am a vampire with British ancestry.
Das Vampire. Um. Okay. My studio. Okay. All right. And I realized I don't have my intro written. Apologies. I'm gonna cough. I'm still
That's
recovering from this RSV.
so miserable.
3 weeks.
Oh, geez.
Yeah.
Is there an RSV vaccine?
Yes.
Okay. I need to
Yeah.
make sure I've had that one. I know I got flu, pneumonia, and COVID.
I didn't know there was a pneumonia vaccine.
Yeah, yeah. You're supposed to wait until you're 50 to get it, but I got it early because my lungs already like to rebel.
Yeah.
So we are indeed double streaming, Ian. We are both on YouTube and on Twitch. We are coming to you on an unusual day because Fraser had the shortest snowbird experience ever and has just returned home from Arizona, where I am hoping he will regale us with news from seeing Biosphere. Yes, yes.
Um,
And in the meantime, there shall be the typing of the words, and the words shall be typed, and their number
okay,
shall
good.
be greater than 3.
Yes. All right. Uh, and then I just got to find the thing, and then the other thing, and then everything is good. Okay, great. Um, yeah, Arizona was a lot of fun. We so I learned that as a Canadian,
Mm-hmm.
I need to provide people that I want to meet with more advanced notice. And so I put out the call to go see the Mirror Lab. I want in at University of Arizona. I wanted to see the Large Binocular Telescope, Mount Lemmon. Like, there's all these great observatories that are around Tucson.
Yeah.
And so I reached out, maybe 2 weeks left in my trip, and they're
Oh
like,
no.
"Oh, paperwork."
Yeah.
And the time of the year, apparently they've closed most of the roads to most of the observatories, so one does not visit observatories in mid-December. And then as a Canadian, it's sort of like one extra level of complexity. And so it was, yeah, it was a funny thing to kind of realize bit by bit, the horrible realization that I had not provided ample. So it's funny. So I talked to the people at the Mirror Lab, and I was like, yeah, well, I'll come down there. And she was like, well, what do you want? What do you want to do? I'm like, well, like I want to bring my camera, set up some establishing
Oh,
shots, talk
there's
to some people.
permissions involved.
Yeah, exactly. Turns out
Oh
that one does
no.
not simply visit the Mirror Lab. One has work to do. So and then I came down with this sickness. I'm like, well, okay, well that just made the decision for me. So, but I did go see the Biosphere 2,
Good.
which was one of the things that I was most excited to see, and it was weird.
Okay, tell us more. Tell us more. I have not been.
Well, yeah. So I mean, like Biosphere 2
Yeah,
was right.
yeah.
1995. They earlier in 1991. Anyway, they built this space habitat in Arizona, and they tried to see if they could seal the place up, and a group of 8 people could live inside, produce their own oxygen, make all their own food,
And they
survive for
forgot
a
that
couple of years.
cement has chemical reactions.
Yeah. So the answer to that question was no. Although I don't think it was their fault. It was just that the carbon dioxide levels were going up, but the oxygen levels were going down. And it turns out that the curing concrete was still absorbing the oxygen. And so the horrible, horrible mistake that they made was a they decided to release a whole bunch of oxygen into it without telling anybody. And so what they should have done is said, got a problem. Everything is going great except for the fact that they're suffocating in there. So we need to give them some more oxygen. Lesson learned for next time. But instead, they just did it and didn't tell anybody, and so it became a public relations scandal, and kind of scuppered other versions of it. But it was like I feel very sad because it's kind of aging now. Like it's 30 years
Mm-hmm.
old, and so you're seeing rust, and it's all
Yeah.
being run by the University of Arizona, and they're doing a great job, and they're doing all kinds of really interesting science experiments in there, but it's not fulfilling its purpose,
Yeah.
which is to be this closed ecosystem where they're testing out what it would take to keep a group of inhabitants alive for an extended period of time in a completely closed ecosystem.
Yeah.
And without that, you kind of just wonder what's the point.
Education.
Like, yeah, of course, educate. Like what is any you know any old piece of scientific apparatus that one might want to walk around and look around, but it's still got like an ocean, but the corals are gone, and it's still got the forest, but the trees are packed in, and things are not sustained. And yet, like, as people are excited about the prospects of living off Earth, they are like, this is the most important experiment that we could be doing. There should be 20 Biosphere 2s, each one learning from the lessons of oh, do I know that I don't have the light on topic? I'm just like, it just showed up. There we go. So it was like, there should be 20 of these. They should be
Yeah.
rotating. They should be learning lessons. They should be iterating. And there are a bunch of others that are being, like, in China. They're doing a version of this. There's one in Europe, but
There's the underwater NASA thing to see if humans can like mentally deal with
yeah,
it.
yeah. So it's like, we just don't know what it's going to be like to live. And then at the same time, people are thinking like, oh, I want to go to Mars. I want to live on a city of Mars.
Yeah.
But there are just so many fundamental questions that we don't answer what it's going to take to live for a long time on Mars, or in space, or on the moon, or anything. And yet that was the place.
Yeah.
Someone had the foresight to say, if we want to do this, we have to figure out how to make this work. And for some reason, just didn't carry forward. And it really makes me sad. And so as I was walking through it, I felt grief,
Yeah.
which was a completely unexpected feeling that I was gonna have. I thought it was gonna be cool and exciting. I was stoked to see Biosphere. I read so much about it, and I just felt I was grieving for 30 years of lost progress,
Yeah.
which was a very peculiar feeling to have, because it was not the one that I was expecting. Yeah. So that's sort of where I'm at right now.
And you didn't make it to the boneyard.
No, I didn't even know that was a thing. So
Next time.
Yeah. I mean, we definitely enjoyed not being in the West Coast Canadian rainforest for about 6 weeks. That was delightful. So, yeah. Anyway, there you go. There's my update. What else did we do? That's it. We did a lot of walks. Spent a lot of time in the desert. Visited all the various parks. It was great. It was a really good time.
Next time, New Mexico.
Yeah. I've got some more friends in New Mexico. I've got family in Albuquerque. So yeah, I think that's where we go next time. Actually,
awesome.
Next time is Thailand. Next time is Uruguay. Like this was running the this was the test of, and I had to come back with all kinds of gear to make my setup work on the road. And again, as I was mentioning last time, right? Like I'm like, oh no, I don't have a way to plug this into that. Amazon, boom, the thing shows up. So
yeah,
it was delightful to have that, and so I was able to work through every single kink in the system and fine tune. So by the end, I was sort of set up and operating out of the facility. I mean, it sucked, but still, like I came back here and now I have gigabit internet again. Oh yeah. Right?
It really is wild how spoiled we get by things like that.
Yeah, totally. So, but yeah, no, it was a lot of fun. It was a lot of work, but it was a lot of fun. And I worked my ass off. Like it was not a
That's
holiday.
your default, though.
That's possibly true. Yeah.
This is why you and I are capable of accomplishing so many random tasks. Is shut down. You're better at it than I am, but your shutdown is I'm going to go do yard work now and move trees.
That's exactly it. Yeah. I came back and the deer had definitely been in and, chomping on things. But all the leaves are off everything. So it's not like you could really do any damage.
Okay.
But still, it was, I'm like, oh, I'm got to harden the defenses even more. So, and I still have this cough. And I apologize again that I'm still going to be coughing a little bit every now and then.
Totally getting my RSV vaccine. Would sign up for it during this podcast, except I need to actually pay attention.
Yes, we do. All right, let's do our jobs.
Okay, I'm pressing record on the audio. I am pressing record on the video. We are recording.
Testing. My audio feels a little hot. I'm going to turn it down a little bit.
I'm going to turn you back up a little bit.
Yeah. What have you got me set at right now? I just don't want to.
Now you're at 100.
I'm at 100 right now?
You're at 100%. Okay. I had docked you down before.
Okay. Yep. That looks good. Weird. It's quiet now. Testing. Okay. I think it's good.
Oh, I'm using the wrong mic, though, for my audio software. One moment, please. Stopping the recording. Glad I looked over there. It was set to my lapel mic.
Do I need to feed power?
You always need to
like
feed
that?
Yes, that's much better.
Yeah. Okay. I've got a new audio interface. Let me just again.
Okay.
Testing. 1, 2, 3. Yeah, that's okay, I think.
All right. I am starting.
Oh, I'm not going to peak for it. Okay.
Okay. I'm recording all the things, and it's actually recording this time. Hi, Rich.
Okay, hold on. I'm also recording. All right, here we go. Astronomy Cast, episode 703, The Solar Max of Doom? Maybe. Welcome to Astronomy Cast, our weekly space journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. I am excited that we're actually taking 2 weeks off because of Christmas Day and New Year's Day falling on Mondays. And I apologize to the audience that we won't be with you, but my house is about to get very clean.
Oh, good. Yeah. Yeah. And my forest is about to get very clean. That's we were talking about this beforehand, that we have different ways of utilizing our free time. And for me, I am going to just continue the defense against the deer,
I
who
need
clearly were in the garden while I was gone.
I need to harden the defenses against the four-legged things that get into our walls and have recently gotten out of the walls into the house.
Okay. Solar cycle 25 is shaping up to be a doozy, with plenty of flares and coronal mass ejections blasting off the sun. As the solar activity continues to rise, everything's shaping up. And we'll talk about it in a second, but it is time for a break. And we're back. So how is solar cycle 25 matching your expectations?
It is actually, so leading up to it, there were predictions that it was either going to be weaker than the last one, which was pretty weak, or it was going to be a whole lot stronger than the last one. And it turns out in reality, it is stronger than the last one, and it's looking kind of normal, but we are in a new and interesting place with this particular solar cycle. So 11 years ago, so we're talking 2012, there weren't that many CanSats. Like, it wasn't a thing yet. People weren't doing small sats. Starlink didn't exist until 2019. And so this is the first solar max since we started trying to fill low Earth orbit.
Right. And so we're learning quickly what impact. So, well, I guess, like, what influence does the sun have on low Earth orbit, on the sun, on its atmosphere, on the ionosphere?
Yeah. So to back all the way up, because I don't think we've explained what solar max is in episodes and years and years and episodes.
Okay.
So our sun has a magnetic field, a very powerful one that influences the entire solar system. And it periodically inverts north to south, south to north in how its magnetic field is set up. And in the middle of this process, all chaos breaks loose. Magnetic field lines puncture through the surface all over the place, creating visible sunspots. And periodically, these magnetic field loops, which are literally loops filled with plasma, snap and send material our way. And there are other things that happen as well, coronal mass ejections, and all of this activity that sends high energy particles streaming towards Earth very rapidly are most likely to occur during solar maximum. And when this wave of charged particles, this front of charged particles, hits our atmosphere, it imparts energy onto the atmosphere, causing it to expand out and increase the altitude at which satellites experience significant amounts of drag. It also causes amazing aurora. So there's this, I want to see the aurora. There's also these charged particles being incident on the moon and on Mars allow us to do really cool science experiments. When we have wussy solar max, we don't get as good at data. So we're in this sad position of, for the not terrestrial science, we want big solar max. For the aurora that are just amazing to see, we want big solar max. But unless you want the Kessler syndrome, you probably don't want it for low Earth orbit.
Right. So if you want to see beautiful auroras, you want solar max. If you want to learn some important new things about the sun at its extreme, you want a powerful solar max. But if you care at all about your nation's infrastructure, your satellite systems, then you probably don't want solar max. And unfortunately, we don't really have any kind of control over this. So when did, and I mentioned in my introduction that we're in solar cycle 25.
Yeah.
So how long does this process take? How long is a cycle?
So to go from one flip to all the way through, so north ends up as south, south ends up as north, takes 11 years. To do all the way back to north is the North Pole of the sun is realigned back where it started is 22 years. So we have the complete cycle is 22 years, but everyone talks about the 11-year solar cycle because maximum to maximum, minimum to minimum is really what has the greatest influence on the Earth. And for the longest time, it was really all we could observe because we're just looking at the sunspots and we didn't have the capacity to measure the magnetic field alignment of the sun in the 1600s when they started observing sunspots.
Right. And so like we get the solar max every 11 years,
Yeah.
but the solar max is whether the sun is configured with the poles flipped. So sometimes the North Pole is at the top, and then other times the magnetic poles flip, and that takes 11 years each time. And so we get a solar maximum every 11 years, but the full configuration. And then we get the solar minimum in the in-between times.
Right.
Yeah. And so I guess, you mentioned sort of, you provided like a laundry list of things that can happen. So let's kind of like break these down one by one here. So what, if you were to sort of describe, you described like the puffiness of the atmosphere, you described the amount of auroras, you described like the effect of the magnetosphere, the effect on satellites and the ground-based electrical infrastructure. So what are the different, like what is the sun doing that is then causing an effect on Earth?
So during solar flares, coronal mass ejections, the sun is releasing a plume, for lack of a better word, of high energy particles. One of the reasons we like to put solar observers out at the Lagrange point between the Earth and the sun is we first see the light of these events. And if it's on the edge of the sun, we know we are completely safe. If one of these things happens and it's pointed our way, we need to know, first of all, is it really pointed our way or is it going to miss us because it's just slightly the angle's wrong? And two, just how fast are all those particles moving? And since a satellite between us and the sun can go, okay, light moving at the speed of light reached me at this time, it will reach Earth at this time. Okay, so the particles associated with that light reached me a few minutes, a few hours later. Therefore, I now know how fast these particles are coming. And we can start to put the power grid that is facing towards the sun for that part of the planet that's going to get hit into safe mode. We can start putting satellites into safe mode. And this ability...
Does anybody really do that, though?
Yeah, they actually do.
Okay.
Yeah, there's alerts that go out. And with the power grid, this is particularly important because we often, especially in the summer and the coldest parts of winter, will run the U.S. power grid, and the Canadians are guilty of this too, very close to maximum capacity. And wires can only carry so much electricity, and they heat up, they sag, and they will eventually break if you overload them. Now, there's the power that's in the power lines because it is getting put into the power lines by the power grid. Now, if you walk up to any old wire anywhere and you shake a magnet next to it, changing magnetic field, you can generate a electric field. It is far more effective to couple this with a bicycle. But when you see these machines that are using bicycles to produce electricity, it's because there's moving magnets next to wires, and you're effectively moving the magnets to generate the electricity. When charged particles, which are essentially little tiny magnets, interact with the Earth's magnetic field, which is also essentially electric field, it's all the same thing, folks. All of these movements generate their own magnetic field, like you standing there shaking a magnet, but at a much larger scale. And this will generate additional power in the power lines. And Quebec experienced this in the 80s and took out a large swath of the American Northeast and the Canadian Southeast. Do you refer to it as the Canadian Southeast?
No, we should refer to it as Quebec.
Okay.
Yeah. Yeah. I mean, everything's south in Canada. Like, we all live along the border. So
All right, fair.
very few people live anywhere else. So there's the, like, you guys call it Pacific Northwest, and we just call it the West. Right. Right. You know what? We're gonna take a break first, and then we'll keep talking about this. And we're back. So this idea that you've got your electrical cables and you are hitting it with a very powerful magnet, essentially charged particles delivered by the sun. Yes, charged particles delivered by the sun, and you're getting these. And you know, the most famous example of this, of course, is the Carrington Event back in the 1800s, where telegraph poles caught on fire because you had too much charge moving through these wires. It wasn't prepared for that at all. And so, and you know, they had no insulation, and so these things caught on fire. And you said in Quebec, in various times, you get this situation where the wires run through, the transformers below, the power grid goes down, everything interconnected.
Yeah.
And so it's a very bad day, especially during the Canadian winter. There was an ice storm when this happened. So it was a very, very bad day in Canada. Yeah. And just a hint of what's possible. The other thing that's really interesting, and we actually had this, the most powerful solar flare during this cycle just happened on Friday, the Friday before we're recording this. And it caused a radio blackout on the hemisphere of Earth in certain wavelengths that are pointed at. And so this is devastating for air traffic control systems, things like that. They had trouble communicating with airplanes. People weren't able to send radio transmissions. They had to wait a couple of hours before they could resume radio transmissions. And often during the most powerful flares, this is a thing that happens. So,
and it's really wild because we don't talk about the radio blackouts. Back when Hurricane Maria was taking out Puerto Rico a number of years ago, there was a radio blackout associated with solar activity. And so while most of us are actually connected through wires to one another, not everyone. So the Carrington Event was in 1859. And yeah, there were telegraph systems that worked just fine for hours with no actual battery power going into them. Just the solar power was causing this to happen. There's amazing transcripts of telegraph operators being like, okay, take your battery off. All right, this is working better. Absolutely amazing. There was another storm in 1872 that caused fires. And there were actually aurora seen in Bombay and Khartoum, which are rather...
That's south.
Yeah. Yeah. And then in 1921, we had more things that caused fires, this time in New York City, and it was associated with the trains more. So we know that in recent history, at least 3 times in 60 some odd years, there were massive, debilitating storms. And we've just been lucky in the modern era.
And it's also interesting, like, astronomers have seen flares even more powerful than the ones that triggered the Carrington Event, just not headed towards us. So they've watched them pointed, the sun's gun went off in a different direction than where the Earth was.
Yeah.
But if it had hit us, it would have been devastating. And the
Yeah.
thing that I always find so interesting is that there are these tree ring effects that have been found where very powerful solar storms have hit the Earth, and it caused a sort of cascade of, I think, carbon-14 to be released into the atmosphere, and then it was drawn up in trees, and they were able to see these. And there was like
Yeah.
6 of these events over the last like 2,000 years. And the craziest part is that the Carrington Event doesn't even register. So there are 6 events, maybe more, that are vastly more destructive, more damaging than the Carrington Event that have happened within a couple of millennia. All right, we're going to talk about this some more in a second, but it's time for another break. And we're back. So, we talked about this specific cycle leading up to this, and we know all the interesting things the sun can do. What was the expectation of astronomers that what was going to happen this cycle?
So we do run computer models. We don't have as much data as we'd like, since stereo A and B aren't both currently working to give us data on other parts of the sun. That was one of the glories of having stereo A and B, is we got a fuller picture of the entire sphere of the sun. But going into it based on sunspot numbers, based on activity levels, based on all the things that we can measure compared to past behaviors, it's basically meteorology of the sun, folks. It's not an exact science. There were 2 different models. One said that we would have a lower solar max, so less activity. The other said we'd have significantly more. And at this point, what we know from past behavior is the rate at which the number of sunspots increases from basically 0 at solar min to whatever the peak is going to be any given cycle. The rate at which that goes up tells you how quickly solar max is coming. Latest data shows we're about a year out right now.
Mm-hmm.
And it also indicates to an inexact degree what that entire curve is going to look like. And it looks like we're probably going to peak at a fairly average peak. So last year was significantly below normal. This year's looking like it's going to be kind of average a year from now. But there is very little relationship between how big the coronal mass ejections, how big the flares are, and solar max. What matters is the bigger the solar max, the more events there are, and the higher the probability of one hitting us rather than empty space.
And it's interesting. I don't know if you're looking at the graph of the number of solar flares that have happened. And so in 2021, there was a couple of small flares. In 2022, there were about 25 powerful flares. And then in 2023, there have been almost 50.
Yeah,
and so it just keeps growing.
I have to admit, I had a long, hard discussion with my bank account last week, because this solar max is looking like it's going to be really cool. And the time to see it is going to be either next fall, so fall 2024, around equinox, or March 2025 around equinox. Aurora are always best around equinox. You can see them the entire winter long. That's just when they're typically best. So increasing statistics and wanting some daylight wherever I go. But the best places to go for aurora trips are super expensive. So
Iceland.
I'm apparently going to wait another 11 years.
Right.
But
yeah, I might go to Iceland this fall.
Did you see the pictures from, I think it was 2 nights ago?
No.
There are amazing. So the Blue Lagoon Resort, which is north and west of the city of Grindavik, which is near where this brand new eruption went, the Blue Lagoon Resort, with its natural springs, does aurora watches. And while the
Mm,
resort is completely closed pending volcanic eruption, there's still cameras. And they
yeah,
have pictures that I saw posted of aurora and baby volcano. And it was
that sounds
super
great.
exciting. I want to
Yeah.
see aurora and baby volcano.
Yeah, yeah. So I'm just comparing the 20 cycle 24. And
Yeah.
so it peaked about 40 solar flares. So we haven't hit solar maximum yet, but we're already 10 flares more
Yeah.
than the peak of cycle 24. So I would say it came on pretty fast
Yeah.
and has grown quite strongly. And so it could very well be when you look at, like, it took 4 years building up to the solar max. As you say, we have one more year. And so
Yeah.
if these things continue, then there should be another flare. Now, for those of us who aren't worried about infrastructure, um, like, what this really means is this is your chance to see an
Yeah.
aurora.
Go look.
Go. Yeah, yeah.
There.
And every time we talk about this, like, find some kind of aurora alert app. No, we don't have any recommendations. I'm sorry. Um, put it on your phone, get it to tell you when there's activity in your area. And this year, it could be pretty far south. There were
Mhm.
some auroras that were seen in northern Arizona.
Yeah.
There were auroras that were seen, in France. So, um, as this solar activity builds, and as you get more and more of these powerful solar storms, then your chances of seeing an aurora get better and better. Find a place that you've got a nice view to the north, where you've got
Mhm.
good dark skies. Set up your aurora alert, and then when the aurora alert comes in, go for it. Go to your spot, and maybe you'll see something, and maybe you won't.
Yeah.
But, I always say you miss 100% of the auroras that you don't try to see.
And there are amazing destinations in Alaska, in all of the Scandinavian countries, in
Yeah.
Iceland. Choose the ancillary activities you want, whether it be a spa, horseback riding, or just a private glass covered igloo to spend the night under blankets looking at the stars. There is an adventure for you out there waiting to happen. Maybe this time, maybe in 11 years. It depends on your bank account.
Yeah, yeah. So, I mean, if people want the low cost version, and you
Hmm.
live somewhere in mid latitudes,
Yeah.
like a person like me, I live in Canada,
Yeah.
obviously, but I'm Southern Canada. It's not great, but Northern US, the middle of Europe, Japan, South
Yeah, the app is
Australia.
just fine for you. I've seen
Yeah, yeah.
amazing aurora from New Hampshire. Absolutely
The
amazing from New
Yep.
Hampshire.
And the greatest aurora that I ever saw was from this process.
I was
But
scared of aurora growing up. Did you see aurora growing up?
oh yeah, yeah, quite a bit.
I didn't know what they were, and they looked like the ghosts from the old Warner Brothers cartoons coming up from the horizon.
Well,
So
I mean, the thing
tell your
that's so
children what aurora are, people. Tell your children this is the
right.
lesson.
Yeah, well, and they're very different. And
Yeah.
so, like, I've seen ones which are these green sheets. I've seen ones that were like red stripe that just runs across the entire sky, like a seam in
Yeah.
the sky. Kind of bizarre. But yeah, and then I think if you have a little more money, this is it. This is your, next year you're going to want to go to Norway, to Iceland, to Alaska, to northern Canada,
There is now
southern Argentina,
there
Tasmania. I'm trying to think of places where you can go. Antarctica. This is your
Patagonia.
chance. Yeah, yeah, Patagonia, and it should be good. But
Yeah.
but I mean, I think the lesson that we've really learned is you have to just go. Like,
Hmm.
you still haven't seen true totality of an eclipse yet,
No, because I
and
keep
you've
getting rained on. I keep trying. I do keep trying.
yeah, yeah. And so, like, you're going to try again in April.
Yes.
Round 4 for Pamela, round 2 for
Yeah.
me. And so you've just gotta, like, there's no guarantees
Right.
in this world.
Right.
when it comes to astronomical events. And yet, if it plays out, then wow, is it amazing.
Yeah.
And so, like, who knows? Like, you never really know. But when you look at how fast this solar activity is coming on, how high it's already reached
Yeah.
a year away from solar max, it does feel like it's going to be a very good year.
Yeah. Oh, okay. So I want to go. I'm clearly going to be waiting. But just remember, folks, do pay attention to space weather. And we're about to learn things we never knew about how Starlinks react, about how CanSats react. And the scary thing before we go, I just want to make sure everyone knows, is when that atmosphere gets bigger, it's creating new drag on spacecraft. And the amount of drag they experience is related to the direction of motion, the shape of the spacecraft in that direction, and that shape of the spacecraft in the direction of motion adds a chaos factor that we don't always know how to calculate. So when these flares hit the planet, everything's orbit changes in a somewhat unpredictable way. And as we're filling up low Earth orbit with more and more and more stuff, collisions are getting more likely. At some point, this is going to cause the collision. So it's all fun and games until somebody's spacecraft hits somebody else's spacecraft.
Yes.
So enjoy it while you can and realize what is fun and games to us and our cameras is also devastating to satellite operators.
So there was a paper that came out, and we reported on it on Universe Today. I haven't seen
The
anybody else
FAA
report on this yet. No. About that essentially we are putting more charged particles into the atmosphere.
Oh, yeah.
And so we are creating our own version of the ionosphere. And when we reach millions of satellites with billions of pieces of space junk, it will overwhelm the Earth's natural ionosphere with unpredictable results. And so just when you thought there was like, that we'd found all places that we could, all the environments that we could affect, it turns out we might cause damage to the magnetosphere of Earth with all of our satellites.
Oh, dear.
Isn't that great? Yeah.
Happy holidays, everyone.
Happy holidays, everybody. Yeah.
Hey, today is solstice or tomorrow is solstice?
Tomorrow.
So happy solstice and merry perihelion in early January.
All right. Thanks, Pamela.
Okay, thank you, Fraser. And thank you to everyone out there who helps us through Patreon. This week, I would like to thank the Big Squish Squash, Justin Proctor, Cooper, Jordy Ivanov, Benjamin Mueller, Don Mundus, Aaron Zegev, Peter, Philip Grand, James Roger, Sam Brooks and his mom, Cami Rassian, Sean Matz, Nate Detweiler, Dean, Kimberly Rake, Disastrina, Jeff Wilson, Tim Garish, Paul D. Disney, Janelle, Michelle Cullen, Benjamin Davies, Gabriel Galfin, Dwight Ilk, Philip Walker, Brian Kelby, Jordan Turner, Bob Zatska, Sydney Walker, David Bogati, Maxim Levelt, Justin S., Ruben McCarthy, Arthur Latz Hall, Paul Esposito, Jason Cardokas, Ron Thorson. We only have 2 episodes in December. I'm sorry. Robert Hundle, Daniel Donaldson, Time Lord Ira, Frank Stewart, Christian Golding, Jeff McDonald, Lee Harborn, Nicholas Cunningham, Cody Netchka, Conrad Haling, and Slug. Thank you, everyone.
Thanks, everyone. And we'll see you next year.
Bye-bye. And then they saved.
And I can upload now.
Uh-huh. You can without destroying everything.
It's true.
I love that solstice and perihelion are just a couple of weeks apart for us Northern Hemisphere people because it really does make winter slightly better.
We're at the closest point to the sun during the winter.
Yes.
And the farthest point from the sun during the summer in the Northern Hemisphere.
Yes. And this is why southern seasons are slightly more extreme than northern seasons.
Okay. Whoa, S28 static fire 10 minutes ago.
S what static fire?
S25.
Okay.
S28.
So
So,
Starship's at it again.
yeah.
Cool.
Good luck. Good luck, Starship.
I want them to, if they go boom, at least make it far enough away from the coast that the coast doesn't see the boom.
Where did I save that? What?
I don't know where you saved it.
Oh, there it is. Okay.
Okay.
Everything's fine.
Okay. Looking for questions in the chat. There are many hearts in the chat. It turns out there's
Internet. My internet is so fast. Oh, and done.
There is both a spaceweather.gc.ca and a spaceweather.gov. So pick your government for your space
Right.
weather source.
Right. Pick your country.
Yes.
Arjun asks, do the flares come straight out from the sun or do they curve?
I don't know.
It's not that simple. Like,
Yeah.
it's not just there's a powerful flare on the surface of the sun, that there's like sometimes you get flares, but no
It's
coronal
like-
mass ejection and no damage to Earth. In other
Yeah.
cases, you get the flare, the coronal mass ejection, the charged particles. So there's more. This is one of the big questions that they've gotten. In fact, we didn't talk about this too much, but the whole space warning complex with all these new telescopes that we have, all of the missions that are out there, the goal is to give as much warning as possible when a new flare is about to hit us and cause damage. So that, as you said, you can shut down things, you can take preventative measures. And we're still figuring out what are the signs of a powerful, devastating flare as opposed to one that's just a powerful activity on the surface of the sun, but doesn't mean that we're going to take damage. And that's still an unknown.
And to completely map how the particles move, you have to have stereo imagery of it, which is what the stereo A and B were used for. And then you also need to have the detectors in the path. And so it's hard to measure in detail.
Yeah, totally. And Arjun asks, is there anything that could be put in between the sun and the Earth that could ameliorate the effects of a coronal mass ejection? If it would not be practical. I mean, if it would not be practical, then yes, you could put a gigantic sheet of grid of metal, and that would probably absorb a whole bunch of the electrical energy and have less reach Earth. But yikes.
We kind of need sunlight. We are basically plants.
Right. Yeah. The Raven Lillian says, so if this is solar cycle 25 and the cycle is 11 years long, then can I assume they've been recording data in some way for 251 to 275 years? Yeah.
Yeah. It's one of the longest running data sets. And part of the glory of being able to do this is all you really need is a pinhole in a super dark room to project the sun onto a wall. And while it's preferred to use lenses to create the larger, crisper image than you get from a pinhole, we've had the technology to do that since 1609. So,
and what they're doing is they're, for the longest time, what they were doing was counting sunspots.
Yeah. And they still count sunspots.
And they still count sunspots. Yeah. Every sunspot gets a number. And you get these interesting things. Sunspot complex 3842 has rotated. Because that's the activity tends to come out of the sunspots.
Broken symmetry waves at Raven Lillian across the platforms from Twitch.
It's like they're mirror universes.
It's very true. I wonder which one has Spock with a goatee.
Yeah. Clearly, I'm in the evil universe, right? I'm evil Fraser. Those are all the questions I have over here.
I'm not seeing any questions over on Twitch.
Oh, Aaron Anathema says, Aurora collected the poles because of the magnetic field or the rotation?
The magnetic field.
Yeah. Yeah, I
And
mean, the Earth is like a big bar magnet.
and the reason that we get better aurora around the equinox is because of the alignment of the magnetic fields between the Earth's field and the sun's field. We discussed this in an episode we probably recorded at least 8 years ago.
Right. Yeah. Yeah. Deep into the archive.
Alara Sophia asks, do you happen to know if Soho is still working and recording observations? Yes, it
Yes.
is. Soho is the undying spacecraft.
Yeah. It's solar powered.
Mhm.
Right. Yeah, I mean, that's the great thing about solar powered spacecraft is they can last as long as, I don't know, their gyros hold out.
Yeah, and Soho is cool because it's very good at finding comets that are nearing the sun and potentially dying in the sun. So there have been a whole lot of comets discovered with Soho. I want to say it's in the thousands, and I don't remember
Thousands, yeah.
exactly
Over
how many.
2,000, yeah. Yeah, it's definitely over 2,000. And so a lot of amateurs pour through Soho images
Yeah.
to help discover. Although now machine learning algorithms are doing it
But
too.
the U.S. Naval Observatory has a citizen science project going for people to actively monitor their data.
Mm.
Humans are still better than machine learning. For now.
Right. Yeah, for now. Beep boop. Oh.
Everyone go get your RSV vaccine. This is me opening the window back up to remind myself to go set my
Remind yourself.
appointment.
Go
Yeah.
get your flu shot. Yeah.
Already
We
did
tried to get
that.
we tried to get our COVID vaccine, but we didn't have
Yeah.
time before we left.
Oh no. You
Mhm.
came to the US with, oh, you're brave.
I
I mean, I
know.
knew that, but still.
Yeah. Yeah, I
Ugh.
know. There's plenty of though, and the one that was the scariest one that's roaming around is a gastrointestinal disease that people are getting. Like it sent a couple of friends to the hospital from dehydration.
Oh God.
Yeah. So that's the one I really didn't want to get. I mean, I don't want to get any of them.
Yeah. I'm going to She Podcasts at the end of January. I've been notified I'm a finalist for a Women's Lifetime Achievement Award in podcasting.
Right on.
But it's in Orlando, and so I am going to go, and I'm also very trepidatious about what I'm.
Yes.
Yeah, there shall be so many masks. Every outfit is going to have multiple masks that I'm taking with it, just like you might take like extra underwear.
Right.
I don't
Well,
normally,
can't you
but
turn into like a cosplay, like some
pretty
kind of
much.
cyberpunk
Yeah,
post-apocalypse with your like respirator?
that's pretty much going to happen.
Yeah, that
So,
sounds good.
yeah.
Yeah. Well, you know what? Why don't we wrap things up then? I don't see any more questions, and I'm going to protect my voice. So, thank you, everybody,
Thank
for
you.
joining us today at this non-standard time. Everyone, have a great holiday, and we'll see you in
Yes.
a couple of weeks. I hope you have a great time. I know I plan to do absolutely nothing.
I'm going to clean. And
Yeah,
you know you're going to do yard work. You know you're
I'm
going to
gonna.
do
Oh
yard
yeah,
work.
no, absolutely. That's the plan. This is when you can actually see through the forest
It's true.
when the leaves have all fallen off the trees. So yeah, awesome. Well, another great year, and we will see all of you next year. Thanks, everyone.
Bye-bye, everyone.